without further ado, I might stop sharing my screen, and I might pass it over to my esteemed colleague, Nathan, to start sharing his slides. But look, just for those who aren't familiar with our esteemed panelists here today, and you can start that slideshow if you like, Nathan. But look, first up, Nathan's the star of the show. He's our designer, or one of our design and specification engineers, and he's been a key part of our team for almost 4 years. He's a great passion for the environment, and he's designed thousands of stormwater treatment assets to help better protect our oceans and waterways. Harout, I think he's been around Ocean Protect's halls for over 10 years now, been in the industry for 15, which is almost impossible because he can't be day over 21. Yeah, look, and he's obviously well known across the industry, and I'm sure he's dragged in a few punters today. And obviously, last but not least, Michael Wicks, Technical Director of Ocean Protect, all-round nice guy, and leads up the company, the R&D stuff, and about 1,000 other jobs. So welcome, gentlemen. And I'll put you in the tender care of Nathan. So take it away, Nathan.
Thanks, Brad. Yeah, hey everyone, and welcome. Thanks for tuning in. Just quick shout out to, I think we've got a few international listeners on this one. So yeah, just today, I think we're just going to have a talk about Filterra biofiltration in the real world. We'll just look at a few examples of the systems we've installed over the last few years. But look, it's my first ever webinar, so I'm quite excited. As an engineer, I feel like you don't really get this opportunity to sit here and talk about something you're passionate and interested in, for a good 20 minutes. So this is going to be quite fun. And look, I think I'm in a pretty good place to help lead this discussion. As I said, I joined in 2019 and immediately was kind of thrown into the world of Filterra, and I was able to be involved, I think, in pretty much all Filterra systems that have come across our desk since then. And I've been able to see the progression of Filterra, so it's quite exciting. And look, I think a few of you are probably already aware about why Filterra is so resilient and how it works, but I will go into just a brief discussion on it just for those who aren't aware. I'll try not to babble too much. So Filterra, it is bioretention, but it's smaller. Actually, I'd have to say it's about 1/5 of the size of conventional bioretention, about 20 times the flow rate. And look, I think we can all acknowledge that there are some typical issues with conventional bioretention, whether it be in the design, implementation, installation, maintenance. So Filterra has looked to solve these issues whilst looking to increase resilience. On the screen, you can see just a typical diagram. We've got a bioscape on the left, a tree pit on the right, and just a few, features of Filterra. You've got that external offline, so the high flows as well as base flows are able to bypass the Filterra, so we don't overwhelm. We also have an impermeable liner to prevent the migration of base flows through the system. The distribution network, in the example you see here, we've got a bubbler system, but we have multiple ways that we can organize this or design this. You'll see a few through the slides. There's that mulch layer for that extra protection. We have a high level of QA and QC on every batch, so we design this to consistent specification, and all of this whilst providing a turnkey solution. So we are involved in the design, but we're also the ones who will install the system, and we'll also do that first year of maintenance. And this is all done whilst being able to, provide additional land back for the end user, whether it be for additional lots, parking, open space, the like. So this is going to be the key today, I think. It is bioretention. As you can see on the screen on the left, we have that bioscape again. On the right, we have the tree pit. These are actually two examples we're going to go through today. I personally think they look quite good as well. Let's just briefly touch on performance data. We've got data coming out the wazoo. It's all publicly available. It's all there for you. If you can't find it yourself, it is on our website, but if you struggle, just give me a call. And just like conventional bioretention, Filterra does require maintenance, just like with any stormwater asset. And the maintenance, it's just like conventional bioretention. You're checking on plant health, de-weeding, removing debris, all of the like. And anyone can service this. It doesn't have to be Ocean Protect. There's easy access, just like in conventional bioretention, with a slightly less, planting density. So it's, could be a little bit easier to get rid of some of that mess. You're replacing that mulch layer every 6 to 18 months, as you would say for a GPT. And then sediment fallback is just like conventional bioretention. They act for that extra little bit of settlement. Just you would maintain them like you would any other system. When it comes to the specification, I do want to say, try and get us involved as early as possible. We want to work on these Filterra projects from start to finish. You know, we'll assist with your modeling, we'll do specification sketches, we'll do detailed drawings, we'll work with consulting engineers looking at hydraulics, making sure the system is going to, you know, operate as we want it to. You know, working with contracts to make sure everything's simple and easy for them to do. It's all set up for us when we get there. We're working realistically with all stakeholders to ensure everyone is happy and the vision is clear. And, you know, we're just about to get into the fun stuff. You know, we've done a few of these systems, about over 100 in Australia already. About 9,000 have been installed in the USA. So, you know, got a bit of experience going on here too. So here's for the fun stuff. We're going to start looking at some of the real world Filterras that we've put in. This is the list of the ones we're going to go through. We're going to start at the beginning at the first Filterra we installed. That'll be Warwick Farm. So these are 2 basins, 120 and 140 meters squared each, installed in November 2017. It's a bit before my time at Ocean Protect. So Michael, do you want to tell us about your experiences on this one?
Thanks.
Sure,
Right, I've got a bit
Mike,
of a problem with the
just
internet here, but anyway, yes, we're always having some issues. Just a problem with the internet here. Can you guys hear me okay?
Yep.
Yeah.
I got you.
Excellent. Okay, great. Look, this was, thanks, Nathan. This was the first system we installed in 2017. And the client for this one was just looking at a direct replacement to the bioretention system, but they wanted a complete turnkey solution. They was
Having some problems there with
well. So are we okay? Harout, do you want to pick this one up?
Yeah, I might jump in there. Thanks.
Mike might be an idea. As much as we love your beautiful good looks, I think it might help if you turn your camera off. That generally helps with streaming. How about that? Can you talk? Say a few words now. No, I think.
Yeah, I think.
My dulcet tones.
Struggling.
Yeah, struggling.
We'll see how we go.
I'll take over there.
Michael? Yeah. Sorry, Harout.
Yeah. So yeah, these were the first, as Mike said. Client came to us looking for a solution to the traditional bioretention systems that were specified. Same footprint. What they were after essentially is just the full turnkey service. They weren't interested in multiple contractors sourcing materials from different suppliers. They wanted a whole system from start to finish. You know, with obviously a high quality system in Filterra, and us with our services being able to go in there and install within, unfortunately, a bit of a concrete box. Sometimes we don't have the choice of the surrounding retaining structure, but we did what we could with the area. So 2 systems, in this case, this side, Warwick Farm, adjacent to the Georges River. So it's a beautiful catchment with the horse stud upstream and the river to the right. The river does rise and inundate these systems from time to time. So the Filterras had to deal with that. And they've been able to withstand all of that. Maintenance has been minimal on these, unfortunately, but what it's shown is the resilience. So offline systems, GPT upstream, 4 bays, multi-cell systems. You can see the plants here are absolutely thriving. Some of these are up to 6 meters tall now. We just went out there to get a couple of photos of recently from yesterday, actually, just to see how it was going. And like anything, obviously you can do with some maintenance, but it's absolutely thriving. So very proud of these 2. And what you'll probably see with some of the case studies Nathan will run through as we go move on through the presentation, there are a multitude of plant options as well. They don't have to be big trees and shrubs. You can have grasses. You'll see all those in the examples anyway.
Just on the topic, and I think Mike's still struggling with the internet, like you mentioned the creek overflowing. So it's right next to a major waterway, which has inundated into these systems and deposited a whole bunch of sediment over the surface of the system. But and I'm sure the guys involved could attest to, it was just a case of going in there, removing the sediment, removing the mulch, which protects the filter media. And I know Mike and Blake did a hydraulic conductivity test after that flood event, and it's still drained as per spec. So
yeah, absolutely right. And that's all you would need to do. It's the mulch layer that's protecting that media. So it's a matter of just going in there and replacing that, as you said. The conductivity testing, whether it's on that system or other sites that have been continually tested in the US, sites that have been tested for years, and the systems are doing very well. And this site here, the Kingswood campus site as well, is an example of that scenario. This is our test site. I don't know, Mike, if you're back online and you want to
I'm
talk to this
back.
one.
I'm back, Harout, for how long? Who knows? Yeah, I'm still on the Warwick Farm last slide, but the site out there at Western Sydney was our test site that we started having a good look at in 2017, and it's a smaller tree pit type of system. And effectively, we looked at doing some long-term monitoring of the system out there for water quality, measuring flows and bits and pieces and water quality as we went through. The system is much, it's just a tree pit system. Takes surface flow, because obviously Filterra can take surface flow or pipe flow. It doesn't really matter which one. And so we took surface flow because we had better control over the test site itself and less error. So that's been out there now for quite some time. We're 5 years in to our testing. We'll continue on because we seldom see any long-term bioretention removal studies. They're very few and far between. Filterra has done a few, but we're looking to increase that data set on the technology locally here in Australia, continuing for another probably 5 years. So get some real good long-term data out of the system.
The next one we're going to look at is Silverdale. So this is out near Warragamba Dam. This was actually one of the first systems I got to be involved in, although in the later stages of it. And it's also our largest, with one of the basins being 530 meters squared. The other one's a bit smaller at 260. And we installed these at around June 2020. So I think Harout was doing a lot of the background work for this one just before I got to join. So I might hand over to him and see if he's got anything to say.
No, thanks, Nathan. These were two of the larger ones that we've done. There's a couple more now being designed up for stage 2, which is now in construction. So there'll be 4 basins across this site in total. Large residential subdivision designed with a couple of challenges that they had to address, namely the issue with tree clearing. So on a lot of sites, I suspect engineers are facing this one. Definitely had an issue with removal of trees and the cost in doing so. And the developer had to address that by limiting tree removal. Credits were paid to offset. So one of the big things was make these as small as you can, fit within the space that we've got, make them look as aesthetically pleasing as you can. To the right of this site, on the other side of the road, are the show homes for this residential subdivision. They wanted these to look really nice. So aesthetics was key. As I said, tree clearing, hydraulics. You can see as we go through the photos, you'll see the swale to the side, taking overland flow paths, hydraulic challenges with upstream splitter pits and GPTs, and ideally being able to work with an OSB basin adjacent to the Filterra with this basin down the bottom. Key here is that with Filterra, we can put up to 1 metre of water above the system for the 100-year. So we've worked in conjunction with the engineers to make sure the OSD had space, hydraulically function with the Filterra. The Filterra is still able to operate, as I said, with all those hydraulic challenges and space. They ended up looking quite nice. And as you can see over time with these photos that we're flicking through, the plants have matured. They look really, really, really nice. I mean, it's quite nice to look at. Up the road is a traditional bioretention system on a similar subdivision, and it doesn't look anything like this. Not to say that it couldn't, I guess, if it was designed in a similar way, but that's the benefit of Filterra. The aesthetics on this site, I think, are magic. You know, ultimately at the moment, it's going to be very nice for these homeowners to look at this open space, and yeah, it's part of their development.
Yeah, I think these final photos we're looking at, they were taken, I think, yesterday. So yeah, it's thriving. So yeah, on to the next. So St. Anne's, this was our first set of precast Filterra systems. So similar to the Kingswood one, that testing site, these were tree, grate, and curb inlet kind of designs. These were installed back in 2018. So as you can see here, as part of the supply, it was just as simple as supplying a box, and within that box was the media, the mulch, the underdrain stone, and the underdrain itself, just all ready to go. Just drop it in, tie it in with your curb, and get going. This one was installed a little bit earlier in the subdivisional work, so I think only maybe 40% of the homes had been built at this stage. So we ended up finding a few little kind of learning patterns with that. So we didn't get a chance to go down there and, you know, put some maintenance on these until about 2022. So they had, you know, taken a fair bit of sediment load from both the construction and just from, you know, general works. And as you can see, that inlet coming into the Filterra there, that looks like it's quite well blocked with sediment. So Lily from our southern office and myself got to go down there and perform the maintenance ourselves, which has led to the following photos. I apologize in advance, you know, but this is, if they pop up, this is myself just trying to undertake a bit of maintenance here. We came across a few interesting kind of problems. So one of the issues was when I opened up one of the Filterras, I found that concrete slurry had made its way into the Filterra and it had kind of formed a layer on top. So had to smash that down, kind of rip that all out. We took off the mulch layer. We took out the plants in this case. They had undergone a fair bit of wear, and then stripped off, I think we stripped off about 20 to 30 millimeters of media. And then we replaced that mulch, put a new tree in, and just set it up and ready to go. And, you know, we got back into working order. And then the next project we'll talk about, Robina. This was quite an interesting one. I think I might hand this one over to Brad. This was
Thank you. Thanks, Nathan. Much appreciated. Yeah, this is a bit of a different one. This was out at Robina Town Centre in southeast Queensland on the Gold Coast. The client basically came to us, the manager of the shopping centre, which is QIC. They've got a lake there, freshwater lake, and they were just keen to, number one, help protect lake water quality, but number two, try something a bit different. So long story short, we took an existing garden bed immediately adjacent to the lake. And there's a photo that is the garden bed that we used, and basically removed the vegetation, the soil, and basically put in a Filterra system. Now, I think it's, by memory, it's about a 13 square meter Filterra bio. I think Nathan's got a drawing here. But long story short, you can see the system getting constructed. So gravel, under drainage, filter media, and plants. And obviously that was put in March, April 2020. And over time, this system has just grown and grown, and it's certainly received a lot of water. We were basically trying to push it to its limits for a long time, and it held up really well. We're still pumping. It's an automatic pump. It receives water 2 nights a week, on a Monday and a Thursday night. If you're ever in Robina, overnight, I think it comes on at about 10 p.m. at night. And a lot of water goes through this system. It's received very little in the way of maintenance, but it seems to be working really well. We've done testing, hydraulic testing, water quality testing. It's not having to work too hard because the water quality in the lake's pretty good, but yeah, it's certainly looks really good and seems to be providing a decent function. There's thoughts of trying to replicate that in other parts, in other garden beds, do something similar, but there was a bit of a trial system, so something very different.
And on to the next, Bells Creek in Queensland. So these were 2 basins, only 12 meters squared each, and we installed in September 2020. But the interesting part about this one was the original specification had 2 conventional bioretentions, and they were about 5 times the size. So you can imagine, you know, how much of a space saving that was, you know, able to integrate these systems quite simply into an industrial, you know, location. So just here's the drawings that we kind of developed. We went through, I think we got up to revision M by the end of this one. But you can kind of see some of the intricacies we put into our designs and our drawings. We like to be very detailed to make sure it's all very clear and understood. You know, we have our base flow, we have our high flow bypass, we have our, you know, the bubbler in this case is what we used, that mulch layer, which you can't see without sections. But, you know, we try and implement these resilient, you know, methods to try and keep Filterra up and running. We're consistently doing these. And here's the second. So just going through the construction of this one, similar to the last, you know, we had our base geotextile layer with an impermeable liner, dropping the underdrain and the underdrain stone. Media comes in next. And then this is your end product. You know, we're very consistent about the way that we install these. You know, it's us every time. So we're always providing that consistent approach so you can guarantee that quality of installation. And yeah, look, again, I like to think that these ones look quite nice. You know, I don't think actually any maintenance has been done on these ones to date. So this was back in April this year, and I don't think any maintenance had been completed. And as you can see, the plant's thriving. It's all green and lush. This is the secondary system. It had a swale inlet, so provided a new interesting mechanism to try and get it in and disperse and distribute the flow. And again, same again, it's quite neat, quite flourishing, quite green.
Yeah, if I can just take over, Nathan. The key point here is that you physically couldn't have fit these conventional biosystems in at this site, at least based on the design layout that we were provided. And that's how the client came to us. I guess the alternative approach would have been nothing at all, or a complete redesign of the development, or conventional bio with some dirty, great big retaining walls and fences, etc. And so the heavily constrained site, you saw a fire hydrant in the previous image, buildings, etc. Because of the land savings, recognizing that these systems were 5 times smaller than what was actually specified, we're able to basically better integrate these systems into the site. And I reckon most people, if they walk past it, they wouldn't even know what it was. And that's the way we like it. Something that's really well integrated into the landscape. And recognizing like the photos that, if you go to the next photo, Nathan, man, this is just what a 2.5 years worth of vegetation growth. I think in the years to come, it'll just get bigger and bigger and just blend into the landscape.
So New Norfolk in Tasmania, this was one of the next projects. So I had the opportunity to be involved in this one from start to finish. So these were 2 basins installed in a subdivision. Again, we'll make that point again. We were able to save a significant amount of space with these implementations. These were installed in June 2022. But the thing about these ones that I'm kind of quite happy about is that we got in early, as I was talking about, as I've repeated, what I found when I first looked was that there was an OSD upstream, and the thing we wanted to make sure was we were going to work hydraulically with everything around. We don't want to drown that orifices, trying to keep everything working how it's supposed to. So we got in early, we worked with the engineers at Aldermark on this one, and ended up solving problems, making sure it was all smooth and worked as we needed it to. Again, you'll see that repetition of our methodology, impermeable liner, that under drain design, bubbler on top of stone. Then we have our media layer and the finished product. And I think a good thing about this one, something that we'd learned over the time, is that the need to protect these systems whilst the rest of the subdivision building was going on. So this one was put in early. We wanted the plants to get a good chance to mature. So what we've done here is we kept the system offline, so no storm flow is going to be entering this system until when the subdivision is ready to send its water and get it cleaned. And we also installed a double sediment protection fence, so keeping Filterra nice and safe and protected, getting that resilience that we keep mentioning. And this is the second system, again, just here. Very similar look, very similar scenario, working with an OSD upstream, and just making sure everything works. So now we'll flick on to Keeley Park down in Victoria. Now I think I might hand back to Brad on this one. He did a lot of good work in the background.
I didn't do any work, Nathan, but I'll take all the glory. But look, and I should start out by giving a shout out to Alan West from Kingston Council. He's been a real driving force behind this project, and I know he's listening, and I think if we can, we might get him to say a few words in the Q&A. Yeah, this is a really interesting project from my perspective. It was basically a 51 square meter Filterra bio that actually replaced a conventional bio system that was a bit worse for wear. The conventional bio was 170 square meters, and these are some photos back in just recently, and you can see kind of it doesn't look too crash hot. A fair few operational issues, but look, long story short, we took that 170 square meter conventional biosystem and proposed a different solution. So you could argue the definition of insanity is to do the same thing again and expect a different result. So Alan was certainly keen to try something different. He'd seen Filterra, and long story short, we were able to propose a 51 square meter Filterra system, and the rest of the area that was previously used for conventional bioretention system can be used for landscaping, and that's the plan. So you can see the Filterra system getting constructed. As we've seen in the other sort of images, geotextile, liner, under drainage, gravel, filter media, plants, etc. And it's also worthwhile recognizing that we're just working within the Filterra area. The remainder of the surrounding area will be vegetated. And this is only these photos are just over a month old. Mm-hmm. But a key feature of this one, so we talked about a few of these systems have bubble up arrangement to distribute flows evenly across the systems. Whereas this one's a bit different. So Alan, I think, got the idea from a bioretention system in the Edinburgh Gardens in North Fitzroy, which had a very similar sort of flow channel and weir arrangement, and was keen to replicate that for this one. And I reckon it looks, I'm biased, I think it looks pretty good. Give the plants a chance to grow, and you probably won't probably see it in the years to come. But really exciting project. And yeah, taking an old bio system that had some issues and replacing it with Filterra and using the remainder area for landscaping. I'm really excited to see this evolve and grow in the years to come. I think it'll look fantastic.
And just onto our final case study of the day. This is Ingleburn. So this one was quite interesting for me. I think about 4 years ago when I first started, this was the first Filterra specification sketch that I did. And it's 290 meter squared bioscape, and we are currently installing it right now. So you can kind of see the level of kind of preempting we go into these designs. We get in early and we're trying to make sure everything's going to work. So it was a good idea of what was happening. As you can see, again, we had very detailed drawings. One of the interesting, I guess, one of the different types of designs here was that the OSD was actually built beneath the Filterra. So instead of routing our under drain system just to an outlet pit, we just dropped it straight to the slab and got it nice and working, nice and simple. Same sort of things you've seen before, distribution, all of that, it's all there. Harout, I believe you had a lot of context on this one though, so I might just hand over to you and see what you can tell us about your experiences here.
Yeah, it's a bit different with, as you said, with the OSD below the system, but the main objective with this one, and council, Campbelltown Council in this case, had a lot of involvement, and thank you to them and the developer and the engineers. One of the goals was to reduce the footprint of filtration system. The traditional bio would have taken up pretty much the entire open space in this location. The idea was to give back some open space for the development, and in doing so, design up what will probably end up being what I think will be looking quite a nice looking system, obviously with the curves and the arrangement, but it is pretty unique with the OSD below ground, pre-treatment upstream, off fine detail. But yeah, it was unique in that the council wanted some of that open space back, and obviously that was what Filterra was able to do. Obviously, being a high flow bioretention system, and the media being manufactured to a high QA standard, enabled us to obviously pass a lot more water through the system. Hydraulic conductivity being a lot higher, reducing that footprint, protecting it with the mulch layer to stop any of that sediment deposition blocking the top layer in the system. So all those put together, and I think it's gonna look fantastic.
Mm-hmm. So look, here's a few more examples of some other systems that we've implemented as well. We're not going to go into details on these, but we've got one over at Brookvale Oval. You can see one that's been incorporated as part of a playground. There's a planter system, a tree pit as well. And look, the interesting thing is as well, I think you would look at some of these and I don't think you would even realize that this is a stormwater treatment system. This is a stormwater asset. It's part of our integration. That's kind of what we're trying to do. And look, to be honest, we're all quite proud of these systems. That we've put a lot of hard work into these, not just providing a system that we're just going to pop into a detention tank like we do with the filters or ocean guards. This is a whole turnkey solution. These are our fit for purpose solutions. Yeah, Brad, do you want to take us home?
Oh, look, why not, Nathan? Yeah, look, just in summary, I guess some take-home messages. And I'm recognizing we're biased. We're wearing like the Ocean Protect t-shirt. Look, but from our perspective, what is Filterra? It is bioretention, but from our perspective, it is better. Why do we think it's better? There's a number of factors. So number one, because they are smaller, so 3 to 5 times smaller than a conventional bio typically. Because they're smaller, they're generally easy to integrate. So more space for whether it's extra development or whether it's landscaping, parkland, whatever. Obviously makes it a lot easier to integrate more gradually sloping batters as opposed to retaining walls and fences, which we see far too common for a lot of our water sensitive urban design assets. So that's the first point. Second point is the turnkey solution that we provide at Ocean Protect. So if I look at conventional bio, and I spent 18 years doing consultancy doing in conventional bio, you've got one designing engineering firm, then you've got a civil contractor, then you've got a landscape contractor, and then you've got someone often who looks after the establishment, and then obviously someone who looks after the long-term management of the asset. Ocean Protect, we can do the whole thing. We generally do the design, installation, and then that first year of maintenance as part of the deal. So if anything goes wrong, or if there's any dramas, we're responsible. Whereas I think for conventional bio, often an asset owner is left with an asset, and if there's an issue, which there often is, who's responsible for, and then how do you actually go about fixing it? So for me, that's a real key advantage. Third point, performance. So we've got, I think Nathan used the term, we've got data out of our wazoo. So we've got, and it's all publicly available on our website, stacks of data, including long-term studies, both in US and Australia. So and a very consistent performance, really good rates of removal for TSS and nutrients, etc. So we've got a lot of confidence that these systems work. And I've done webinars and presentations about this previously. I don't think the same can be said for conventional bio. The performance results are variable, recognizing that there's a lack of performance monitoring data for conventional bios with the current day's filter media specifications. But that aside, I've got a lot more confidence in Filterra than I would other sort of water sensitive solutions. But look, the technology comes with about 20 years of, or over 20 years of research and development. So there's a lot of technical know-how that's gone into this. So it's based from knowledge in America. Obviously, we've learned a stack in Australia. And now we've done, as Nathan alluded to, we've done over 100 of these Filterra systems across Australia already in the ground. And there's a lot more specified as well. So we've taken a lot of what we've learned from overseas and within Australia, both with conventional biosystems and Filterra systems, and really, I guess, integrated various features to enhance the resilience of these systems. So there's a lot of issues that are commonly seen with conventional bio, excessive sediment accumulation, ponding, filter media specification variations, etc. Washout, erosion, base flows, inundation. We've basically taken all those common risks and essentially mitigated them significantly through appropriate design and installation and establishment techniques. And I think a lot of the stuff that we've learned that we apply for Filterra really should be applied for conventional biosystems as well. Thanks, Nathan.
Yeah, thanks. And thanks, everyone. Thanks for listening. Thanks for letting us babble on a little bit about some of the fun work we've gotten to do. So just again, my name's Nathan. Just call me, email me, come to our office. I'll come to you. We'll grab coffee, whatever. Let's just chat. We can talk about this sort of stuff in a lot more detail. We've tried to be a bit brief here. But yeah, just give us a call.
Oh, who wouldn't want to talk to Nathan? Such a lovely guy. And look, and thanks to the guys who have presented already. And look, thanks to everyone who's attended. But we encourage you, if you've got a question you'd like to ask Nathan or Harout or Michael or myself, please do so. You can put it in the Q&A. We've already got a whole bunch of questions that have already come through the Q&A. And I might just look first come, first serve, basically. And I might just go through, there's a question first up from Craig Norton. Craig asks, do the roots get into the subsurface drains? It might be best, I don't want to steal Nathan's thunder, but I did a paper on this a few years ago. It's called Bioretention Myths Busted. It's freely available on the internet, but feel free to contact me to get a copy of it. We basically, this is pre-Ocean Protect days. We took, and this is a common myth that I saw in the industry. Long story short, we took a whole bunch of biosystems with trees and without trees and put CCTV cameras up the under drainage. What did we find? Nothing. And there's a whole bunch of reasons for that, but generally, quickly, tree roots basically, it depends on the species, obviously, but the vast majority of tree species have their roots within the top 300 millimeters of the ground surface. Why? Because that's where the water and nutrients are in most common abundance. And the under drainage is generally fairly free of any water. So why would, it's different to a sewer. So hopefully that answers your question, Craig, but happy to provide that reference further. And Carlo asked the exact same question, so I'll skip further. Question from Winston Boone. To make the Filterra systems more aesthetically pleasing, does Ocean Protect liaise with landscape architects directly?
I mean, I can answer this
Yeah.
one as part of the kind of series of drawings that we do. We do a planting schedule, and when it comes to that, we do discuss with the landscape architects what plants are you expecting to be on this site, and then we provide our list. It's quite an extensive list actually of all the plants we have on offer, and we'll just make sure that it's all going to kind of match. It's all about that integration that we've been speaking about. So yeah, we do pretty much every project for that planting schedule we will.
Cool.
Can I just add to that as
Yeah.
well? Sorry, guys, just quickly with liaising with landscape architects. We're actually doing that at the moment on a large project in Western Sydney. So it's not just obviously it's important with the planting regime, but also the four-bay structure. So the low flow splitter, the diversion. In this case, on this particular project, we're working in with the architect to actually combine that with retaining structures, sandstone structures and the like. So it all actually blends within the system, and it'll be unseen by others. So you won't see the forebay, but they're all there for maintenance purposes.
Cool. Question from Shane Hardingham asks, most wood-based mulches float and can wash through the outlet. What is the mulch layer you use? If you'd like to take that one.
If you can hear me, Brad, have you got
can
me
hear
there?
you. We can hear you loud and clear, Michael. Your dulcet
Oh,
tones.
excellent. Excellent back. Look, there's nothing really too exciting about the mulch. It's basically hardwood mulch with no leaves and no bark. So if you use a hardwood mulch, nice and dense, quite heavy, and we just run it through a shredder twice. So we don't have these big, massive chunks that you usually see when you buy from Bunnings. Basically, you just shred it twice, use a good source material of hardwood, and the majority of it will not float. And that's one of the QA tests that we do. We ensure that, more than 90% of the mulch in a very short period of time will sink. We do often, though, have an ocean guard just in the overflow outlet riser to capture any, small portion that may move. But after that first storm, with a bit of moisture, a bit of rain, a bit of sediment in there, a bit of organic material sticking it all together, it tends to mat down quite well and doesn't move.
Thank you, Michael. Question from Russell Tate, and I might answer it if you want, but if you want to, please do so. How long does the filtration media last, and how is it cleaned? Look, it's probably the most common question I get asked, and we've actually just released a study today in our newsletter. If you subscribe to that, Russell, but if you don't, I can send it to you. But long story short, if the provided the systems are appropriately maintained, the filter media should last indefinitely and should never be needing to be replaced. But that's if the system is maintained. What do I base that on? There's a few studies. One being long-term performance monitoring studies that show that there's no deterioration in water quality performance. Number two, there's studies from America that have looked at systems 15 years plus that basically have shown no deterioration in ability to drain or treat water. So we're pretty confident that they should last in perpetuity, provided these systems are appropriately maintained. Feel free to add anything as well. I can move on to the next question. And this is we've had this question a few times, so I might just use Koa's words here. But long story short, how does Filterra? How is Filterra so much smaller than conventional bio? Like, what's happening? What's happening in the whole system? Is it the media? What is it? So we've mentioned the fact that Filterra is generally 3 to 5 times smaller than conventional bio. How the hell is that achieved?
Look, Brad, I think it's, as you know, I've been doing this for 20 years with Filterra. There's a lot of QA that goes into the blend itself. So we QA source all the materials, we blend it properly, and we use effectively a media blender to put everything together. There's a good sort of 6 months of QA lead in before we do every batch. And we learned from a lot of the failings of bioretention with, some of the systems, either poor construction or poor design. So, why do we get 20 times the flow rate, the same performance? Because everything is we've really just done a better job. We've refined the process over 20 years. We have good control of all the source material. We know what our PSD is going in. We know every single source bit of material that goes in, and it's thoroughly QA'd as part of our 25-step process before it actually hits the ground. So Filterra is just much tighter controlled than any other bioretention media on the planet. That's just fact. once you get those controls, you can actually then dial in the media and just really hone it down to a a product that performs really well, which is effectively what we've done with Filterra. So it's that continual learning, that very tight QA process, so we don't get much variability, and that's how you can run in the field up to 7,000 millimeters an hour and still get in excess of 40% TM reduction of a system that is 0.3% of the catchment.
Thank you, Michael. And actually, I mentioned Keeley Park project before, and I did mention that Alan West from Kingston Council was watching. Alan, are you there?
Yeah.
Would you like to elaborate on your experiences about the Keeley Park project?
Yeah, Brad, thanks for that. Happy to say a few words from a council client point of view in our experience. I first came across the Filterra probably 3 or 4 years ago. Initially, I was very skeptical, and for the reasons that you just talked about of the why and how the smaller and the faster infiltration rate. I probably gave the Ocean Protect team a hard time with, say, 30, 40 questions to try and break it and justify in terms of why I wouldn't be using it. I was unable to do that. I was pleased with the practical examples, which gave me enough confidence to work with the team to do a detailed design. The problem I was having with and there's 2 strategic reasons I really wanted to try the Filterra. One, the original one, and you showed the photos of it, I had a combined traditional biofiltration combined with a retarding basin for large flows. I was getting a high silt load, which was killing the filter media clogging, and I wanted to separate them out. I ended up designing the Filterra being a smaller footprint, about 300 mil higher, so it was only accepting low flows and didn't accept, wasn't getting the clay load from the embankments around it, and the remainder of it could act as the overland flow path for the larger flows. So we reconstructed, and it's looking good, and it's pleasing, that one. The other main reason is I wanted to do it as a trial because we've got plans for much bigger traditional bioretention, and bigger, I'm saying 1,000 to 1,500 square meters of dealing with 60 hectares up to 250 hectares. Now, for our council in City of Kingston in Melbourne, built up area, don't have the green fields land space, and all our master planning is for the treatment to be fit around existing sports fields. Now, whilst I designed the master plans to fit in those larger traditional ones, the land take from other sports happening gradually eroded that space. And I came across a situation that if I couldn't reduce the footprint, they wouldn't become feasible. So effectively, the Keeley Park one that we designed was our trial. We're happy with that success of that trial, which is making our other projects viable, which otherwise wouldn't be unless I could reduce the footprint. So that's been our experience so far.
Yeah, no, really interesting insights, Alan, and thanks very much for your involvement to date. It's been fantastic to work with you and the council team on this project, and I'm sure we'll continue to keep a very close eye on this project, particularly given that Damien Egan, our national sales manager, lives around the corner from this site as well. So I'm sure he'll let us know if there's any operational issues. But thanks again.
And I'll be keeping you accountable.
Yeah, I'm sure you will. I'm sure you will.
His address.
Yeah, might get a rat's nose surcharge, but I might. I'm just looking through some of these questions are very similar to the other ones. Have any councils rejected any of your projects? If so, what did they not approve? And there's questions around costs, etc. But look, I probably deal with a lot of council approval, so I can probably comment on that one. A lot of councils, at least in Queensland, I see less so in New South Wales and Victoria. I see there's some in Victoria, but long story short, it's probably very similar levels of skepticism to Alan. They just don't believe it works. And also, it is often considered a proprietary device, recognizing that the only really proprietary component is the filter media, the pipes, the plants, the mulch, readily available from others, and the media itself is even made from local sources, but we just can't describe exactly how it's made. That's where I guess the IP is, but that's probably the key thing. There's been a lot of questions around costs, and Norman asked a similar question. How does the cost difference compare between conventional bio and Filterra? Did you guys want to? Michael or Harout, maybe, or Nathan, want to comment on that?
Question. I think that
How
might be
does
for
Harout, you can take that one.
Yeah. How does
Go
the cost
Harout.
of
Throw that one
Good
at
luck.
Harout. He loves that one.
Harout, just a reminder,
Yeah,
how does the cost of conventional bio compare to Filterra biosystems?
Well, when that question comes up, typically in conversation with engineers or clients, to be honest, it's a question back, which is what's the cost of traditional bioretention or conventional bioretention? And it's amazing that it's either we don't know or it's a range of, I've heard numbers anywhere from $250 up to thousands of dollars per square meter. I think it varies and it depends. It depends how well you want to do it. I think.
Hang on, I think
okay.
Alan's going to jump in here. He's got his hand up. This will be good.
Yeah, I am happy to jump in. It's a very interesting question, particularly for councils on it. Clearly, given the smaller footprint, there's a cost saving from a capital point of view. But I was interested in looking through the whole of life costs. And it depends on your maintenance regime. In terms of engaging Ocean Protect of doing the regular ongoing maintenance, it probably may be higher, but only because simply that the traditional maintenance is probably done ineffectively or not effective enough. In our own case, looking at the whole of life of the capital plus maintenance, I found it competitive, and over time we're hoping to be able to take on board more of the maintenance and lower the cost ourselves after learning from Ocean Protect and how it goes over time. So it's a little bit of watch this space, but to me, in terms of the whole cost, it's looking promising.
From the horse's mouth, I'm not sure if you had anything to add, Harout.
I can't say it any better than that.
I'll roll through some of these other questions and I'll try to get to them all. So apologies if I charge through some of them quite quickly. Brett Ferguson asks, is Filterra an approved product for Southeast Queensland LGAs, or are they systems generally only approved for private developments? It depends on which council, as I'm sure you might appreciate, Brett. Off the top of my head, Redlands, Townsville, Bundy, all allow them to be used on public sites. For private sites, they're only allowed for, so Brisbane, Sunshine Coast, Logan, and a few others only allow them to be used on private sites. The similar question was asked for Victorian councils and Melbourne Water. It depends on the council. If in doubt, just reach out to any of the guys on the call, and we'll let you know. To the best of my knowledge, Melbourne Water currently don't allow their use. Probably for similar reasons around, well, they've got that throwaway line in the music guidelines about don't accept proprietary devices, and I think they lump Filterra in with that. A question from Glenn Allen. A lot of the trees and larger shrubs look like natives. Are they generally okay with the nutrient and water load, or is it limited to specific species? Who wants to answer that one?
Yeah, look, I'll take that one. We had a chap by the name of Jeff Hunter, who was instrumental in, wetland design sort of in the 90s when it came to Australia. Brilliant scientist, Jeff. He's retired now, but he basically did our plant palette, which consists of about 25 native trees and shrubs, all shallow dispersive root zone, can tolerate a dry soil as well when established. So yeah, look, it's not an issue for the system. But yeah, definitely natives we chose, and definitely everything that works pretty much on the east coast of Australia, and a good mix of shrubs, grasses and trees as well. So as you saw in those slides there, some of the trees can get over 10 metres, 12 metres. They're not there yet because they're only put in 2017, but we can take a whole range of plant pallets. So as long as we stick to the palette that we've got, we don't have a problem.
Cool. Bill Johnson asked the question, greetings, Bill, from Stormwater Queensland Committee. Has the performance been tested in the field, or has it been all laboratory testing? You might have missed the start of the preso, Bill, but there's been a stack of field testing, both in Australia and overseas. Off the top of my head, there's about 7 field scale studies. The one in Sydney's been going for 5 years now. There was a 7-year study in Virginia as well in the US. But look, all that's public, all that's available on our website as well. Just Google review of the application of Filterra Bio in Australia, and that'll come up, all those studies. But if in doubt, just reach out to me. Oscar asks, Oscar Agay, what sort of flow rates can the system handle? How is scouring prevented from these flows, from high flows? We might touch very quickly. We talked about this at the start. These systems are installed offline, so high flows cannot go through these systems. Again, just reduces that risk of scour and erosion. Can you clarify? There's very similar questions around costs and size. Question from Jason, again around mulch. How do you stop the wood mulch floating and blocking the pits? I think we've touched on that already.
Yeah, as well.
Naramon asks, how often is the maintenance required? Nathan, you might also want to recap that for people who might have missed it.
Yeah, so I think we were recommending that the mulch replacement is every 6 to 18 months, similar to what you would think of for a standard GPT. And then, as per conventional bioretention, you're doing the plant health checks, you're removing all the debris, same frequencies you would for, conventional bioretention. So
Cool.
It's all very similar.
Thanks. A question from John
Nairi as well, Brad.
Which one? Sorry, Harout, sorry.
I think Nairi had a question in there as well about the finishes of the tree pits with the metal grate and the concrete surrounds. I mean, with the tree pits, we can finish those off multiple ways. Some of them are open top. In fact, we've got a couple of Liverpool Council that are open top tree pits on the side of a local road near a shopping centre. We've got tree pit grates on some of them, so it's dependent on what the client's looking for. So again, yeah, we're working with the architects.
Yeah, and just recently we put some fairly unique ones up at Bundaberg. So there is off-the-shelf solutions, but there's also, we can work with the site constraints as well, or the preferences of the urban designer. A question from John Tan: is there a maximum allowable road grade for tree pit to work functionally? We'd like to do that one.
I'll take that. So if we look at just a typical grade of road for a tree pit system, we don't put them on more than 4% grade, but every Filterra system, we don't put it on grade itself, we'll have it flat. So if you're going down a hill of grade, you basically have to have, you get in your grade, you follow that down, you flatten the system up, and then you continue on with the grade. That's how we install them there, but not over 4% as well. So yeah, that's just straightforward part of the design for just a typical tree pit. The other thing with tree pits is we make sure we don't have flow coming straight in the throat. We always run at 90 degrees to the throat, so the water goes in and pushes straight through the opening with the scour stone there, so it doesn't scour the inside of the system out. So again, it's just good practice with any design that you'd probably see with a normal tree pit.
Yeah, thanks, Michael. A question from Winston Boone, and it's in relation to the obviously Ocean Protect does make just conventional bioretention media. A query there, Michael, might be best for you. Does it comply with the CRC for water sensitive cities guidelines in relation to filter media specifications?
So we haven't made it as yet because we had a broken blender, which was a real issue for us for quite some time. We fixed our media blender. We've just produced about 1,000 tonnes of Filterra. We're looking at various specifications of bioretention media to comply with, just different specs. So look, watch this space in the next few months. We're looking to produce a variety of blends with a variety of different sources as well. Now that the blender's back online and we've delivered our Filterra stocks and replenished them, that'll be our next focus on the bioretention media side of the business.
Cool. Question from Shane Hardingham again. Having a new site offline for a time makes sense. However, how are the downstream waters protected during the construction of subdivisions and dwellings that happens while the system is offline? I think my comment in relation to that is that these systems are not erosion and sediment control structures. They are not SED basins. They are for the operational phase. Obviously our recommendation is to make sure your erosion sediment control practices are top notch, and those the Filterra systems just aren't equipped or aren't at least designed to cater for those sediment loads. It can go in there, but certainly not our preference. It just means the system's at a higher risk of having operational issues, which, to maximize the resilience of the system, we're trying to avoid. A lot of comments, people loving the photos, etc. Question from
Brad,
final question.
Brad, I think.
Yeah, you go.
Sorry, I think Alan's got his hand up again. So
sorry, Alan.
Just to chime in.
Patiently waiting.
No, sorry, I just want to comment on some of the questions regarding filter media performance. I think as an industry, we focus too much theoretically on optimum performance on day one. I think most of us and a lot of us, like I'm looking at 2030, 2050, 30 years in the future of the sustainability of these systems. I'm wanting the filter ideally designed to be functioning optimal like at year 10 or so. So when some of these quote ideally a rate of like 170 millimeters per hour, that may be on day one, but over time that reduces. One of the advantages I'm looking at of a higher flow rate media, in addition to the QA and other aspects, is the confidence over time of long-term viability, sustainability for decades. And I don't think as an industry we focus on that enough.
Yeah, totally agree. Well said, Alan. Yeah, look, we like I mentioned before, we do have 2 reasonably long-term studies for Filterra, one being 5 years in Sydney, and Michael's committing to doing that for at least another 5 years. He tells me.
The joys, Brad, the joys. Yeah, why not? Let's just do some more field testing. It's so enjoyable at times when it all goes wrong.
I'm very good at spending I'm very good at spending Michael's money, put it that way, for everyone who's in attendance, if we're having a laugh. But obviously there's another study in Virginia. But again, it's only 7 years as well. Like I want to see these systems working really well 30, 50 years down the track. Even though no one will know that they're there, basically.
Yeah, look, the one in the US, there's a recent paper which Brad alluded to before. It's actually been in the ground 14 years. So, and there's 7 years of data on it, which is quite nice. And what we're finding is that the original Filterra design over there was designed for 2,500 millimeters per hour. Now, 14 years later, it's still achieving the 2,500 millimeters an hour. What we're finding long term, and this is just from this one site, is we're finding that the removal of N and P is actually increasing slightly over time, but the solids, as you probably expect when they fail, you either lose the flow rate or you start to lose solids performance. Solids is decreased, the performance of that has decreased, but only by about 1 or 2% over that term. So look, certainly, Alan, an area for more research, which is what I'm probably more excited about than just continuing on with the field testing, but just to see, as you rightly pointed out, what are the changes in performance from solids and nutrients perspective, and also hydraulic conductivity over a longer term. And so we've just released some data on that today, and we'll be continuing on that sort of field of research over the next sort of 5-10 years.
Right. Look, just very quickly, some final questions. I do want to make sure I'm getting to everyone. Michael Ward has been very patient. He said, how do you get water to the plants where you had the system isolated from the development? Yeah, look, obviously water still has to go downhill and needs an appropriate gradient, but obviously the flow distribution system certainly helps that as well. I think commonly I see very large conventional bios, particularly the ones that Alan was referring to, the 1,000 square meter plus. It's really hard to get water to distribute across the entire surface. So the flow distribution, from my perspective, is really critical and something that really should be replicated in other systems. The conventional
I might just add there as well, early on, if the system's offline prior to development development and the construction staging, you will potentially have to be going out there and watering those plants from time to time, especially like we did with Warwick Farm. When you plant it in the middle of summer, you're going to want to go out and just water those plants just to make sure they establish.
And that's it. And sorry, a key benefit to that is the mulch. Not only does the mulch screen a lot of the solids out and stopping it getting into the filter media, which makes the media last longer, it also significantly reduces the temperature from the top of the mulch to the top of the media layer, that's 75 mil layer there. Obviously, when you have a lower temperature of your surface of your media, you have less drying out and your moisture content stays higher within the soil. So your plants can hang on and survive in periods of drought. So that's, the mulch plays a key role in those longer drier periods without any rainfall.
Final question from Matthew Starr. Has been very patient. The efficiency of the filter media allow for reduced media area, but does it allow for reduced media depth? Look, I can answer that very quickly. The standard, typical, constant proposed filter media depth is 0.53 meters, which is often a little bit shallower than a conventional, but that's our recommended. It's a sweet spot. I think all the systems to date have had that filter media depth. But look, we might have to let everyone go. Everyone's been super patient, super excited. Thank you so much for everyone who's attended and given up their time to listen to us talk about something we're pretty passionate about. If you have any further questions, please feel free to reach out to any of the guys on the call. We're more than happy to chew your ear off and talk biosystems. So, and just a reminder, if you want to see the slides, they will be made available on the Ocean Protect website probably later today, if not tomorrow, along with the recording for anyone who might have missed it today. So again, thanks to everyone who's dialed in today, and I look forward to hopefully seeing many of you in person sometime very soon.
And just finally, Brad, a special thanks to Alan jumping on impromptu as well. Really appreciate it, Alan. So yeah, thanks very much for that.
Wasn't scripted, but it was fantastic. Thank you, Alan. And thanks to Alan and the Kingston Council team on their work on the Killy Park project. Very well done. Thanks, guys. Enjoy the rest of your day.